Hello, in this video we're going to take a look at an alkenes and isomerism past paper question. Don't forget, if you subscribe you'll get notifications if I upload, which I will if I upload new videos. Any requests or any questions, please feel free to post in the comments and I'll do my best to address any questions and upload the content that you crave. Okay, so questions about alkenes. Good idea to review the reactions of alkenes. In fact, it's a good idea to review all reagents and conditions because you'll get marks for them if you know them, and if you don't, well, they're going to be impossible. Also, isomerism, types of isomerism, definitions for isomerism, and specific types of isomerism. So in this question, we're going to look at functional grouping EZ isomerism, but you should probably, or I would recommend that you learn to recognize all the different types, specific types of isomerism. Quite a lengthy question. Have a read, pause the video. Welcome back. So a long question. Right, I gotta say right up front that I absolutely love this question. Later on in the course you might see things like infrared spectroscopy, mass spectroscopy. In year 2 you got NMR, both proton NMR and carbon 13 NMR, and these can be quite challenging topics, and you get a question where you need to suggest a molecule that meets certain criteria, and you go, oh yeah, well this is impossible, I can't do this question because I don't know NMR or I don't know infrared. But it's often not the case. It's probably not those analytical techniques which hold most students back. Being able to suggest a molecule that meets certain criteria is a skill in itself. So we don't need to know anything about any particular types of analytical techniques here. We just need to come up with suggestions. So suggesting molecules which are isomers of C5H10 that fit these criteria. So CnH2n, that suggests immediately an alkene or a cyclic alkane. Decolorized bromine water. So alkenes undergo electrophilic addition reactions. And so A and B, decolorized bromine water, goes from orange to colourless. So A and B must be alkenes. The fact that C does not suggests that C does not have a double bond, so it's not an alkene. Okay, stereoisomerism. So what type of isomerism specifically the alkenes exhibit? Well, some of them exhibit EZ isomerism or isomers. Okay, so some alkenes exist as EZ isomers, and this occurs when each carbon in the carbon-carbon double bond is attached to two different atoms or groups. So there's a little bit to get thinking about now. If you want to pause it here and have another go, if you weren't able to start previously, now would be the time to do that. Okay, welcome back. So let's have a little look at how we can construct our answer. A and B, decolorized bromine water, these compounds must be alkenes. So straight ahead, we've got a suggestion, or we've got a statement of fact there. So the alkenes which exist as EZ isomers, which is a type of stereoisomerism, that occurs due to the restricted rotation around the carbon-carbon double bond. So we're explaining how they arise in the carbon-carbon double bond, or sorry, stating how they arise in compound B. Okay, and one of the carbon atoms in the carbon-carbon double bond in A must be attached to two of the same group, i.e. it does not show stereoisomerism. Okay, so A could be that molecule. We've got the carbon on the left is attached to two hydrogens, or it could be that molecule, again, not branched, and it could be that molecule. Now in this question we could identify the molecules by drawing out the structures, skeletal or displayed, or a little bit of a mixture of structural and displayed there as I've done, or by naming them. So good practice to name them if you can. 2-methyl-butanene, pent-1-ene, and 2-methyl-but-2-ene. Okay, I'll let you have a little look at those, but you could have any one of those. You didn't have to give all three, but you had to suggest a possible structure for A, and A could be any one of those three. Okay, so let's have a little look at B. State the meaning of the term stereoisomers. You'd have to state, I don't believe I put this in the blue text, but stereoisomers have got the same molecular formula and the same structural formula, but a different arrangement of atoms in space. So B could be either that molecule. You can see that the carbon on the left is attached to a methyl group and a hydrogen. The carbon on the right of the double bond is attached to an ethyl group and a hydrogen. It could also be that, and you think, oh, that's the same thing. No, one of them is the E isomer, and the other one is the Z isomer, due to the restricted rotation around the carbon-carbon double bond. So C cannot be an alkene. It does not dechlorize bromine water. So what could it be? Well, a type of isomerism shown between A and B versus C is functional group. C does not have a double bond, so it could be a cyclic alkane. So one example of a cyclic alkane could be something like methyl, cyclomethylbutane, as was shown there, or 1,2-dimethyl cyclopropane or cyclopentane. There is another isomer that I haven't put on there, but if you want to have a go at that, if you want to give me the name of that, or maybe draw a picture and put it in chat, bonus points for that. And here are the names. Okay. So as I said before, if you have any questions, let me know. But this is a great question to review isomerism, and a great way of starting analytical techniques questions, even though it hasn't got any analytical techniques in it. Really good place to start. Comments in the chat. Thank you very much.